Hey everyone, I hope everyone's doing well. So, I hope everyone's doing well. My name is Tony Bichet. I'll be your Physics 2C SI for this quarter. Um, so just as a little reminder, in case you guys didn't thoroughly read the post, the worksheets and this video will be posted hopefully Monday nights. So that'll give you a chance to review and go over it. Maybe write down your questions. And then Tuesdays and Thursdays are going to be my question and answer Zoom sessions or my office hours Zoom sessions. This is a good opportunity for you guys to ask any questions that you aren't familiar with or uh, try to figure out the answers for the worksheets. But yeah, definitely take advantage of this. Take advantage of Dr. Anderson's office hours, your TA's office hours. Take advantage of all of it because the more you expose yourself to the material, the better you'll be able to do in this class. And the most important thing is not necessarily the letter grade, but understanding and conceptually understanding the material. So I know a lot of you guys are pre-meds, so this is definitely super important for the MCAT. So yeah, let's get into this. Okay, so far, you guys have gone over simple harmonic motion, um, and we've gone over simple harmonic motion specifically for pendulums and springs, masses on springs. And we've gone over the various equations, and we've derived the equations for velocity and acceleration for the position function for simple harmonic motion. This is definitely something that is crucial to know for this class, other classes, any math class you could take. This unit circle, these sine functions, these sine and cosine functions. So, in my opinion, this is something that is kind of difficult to remember long term. So I constantly find myself trying to relearn it, memorize it. Um, but yeah, this is definitely something that you want to put into your memory for sure because it will help you definitely. So now we're gonna get into simple harmonic motion, and these three equations should look super familiar to you guys. We've tackled it in lecture a bunch of times. Dr. Anderson has. Um, so one thing I want to note about this, one thing I want to note is that this position function can either be sine or cosine. And this is just a question I wanna ask you guys, and then we can go over it in the Zoom session tomorrow, or actually comment in the video what you think the answer is. But if we wanted to make this function, let's say we have a curve, a position curve, and we wanted to, instead of make it a sine function, we want to make it a cosine function. What is going to be different about the equation? Specifically, what's going to be different about the total phase? So yeah, think about that and let me know what you guys think. So, um, and we see here we have velocity and acceleration. Something to note is that velocity is just the derivative of the position function, and acceleration is just the derivative of the velocity function. And you guys are super familiar with taking derivatives, so if in the test you guys do have, I think you guys have the equations with you, but in case you forget, this is always um, this is always something that you'd be able to do on your own. You don't need the actual equations for velocity and acceleration to remember what they actually are. And knowing that it's a derivative will help you understand the graph better. And I'll show this in the next slide, but definitely keep that in mind. That these are just derivatives of the position function. So yeah, the A stands for the amplitude. This is the height of the curve from the usually it's the y-axis if it's not shifted up and down, but from the middle to the highest point. So if the amplitude, if A equals 1, this is just a regular sine function. the highest value is 1 if there's no um, um, translation up and down the plane. And so, yeah, I just said this. D is going to be uh, translation, so moving it up or down, positive or negative. And then this total phase in here is where it gets a little bit tricky. This omega function is the angular acceleration, and this is given by 2 pi over the period. It's shown here. So the period, again, is how long it takes to repeat itself. So we'll be able to see this in the graph to kind of like put a picture to these words or to these equations. The time is going to be, most likely it will be given in a problem. For instance, like find the position at time t equals 0.3 seconds, for example. And then this phase constant is just a right and left shift. So D is a up and down shift. The phase constant is a right and left shift. So in terms of the phase constant, it's going to be, it's a little tricky to, so if it's shifted to the left, the graph is shifted to the left, it'll be plus. The graph is shifted to the right, it'll be negative. So it's kind of backwards, but you guys will get used to it the more practice we do. So now we're going to get into position, velocity, and acceleration graphs. So one thing I want to ask right now is, what function is this that's shown here? What function is this? You guys can answer in the comment section. But yeah, as we see, the period is going to be from here to here. So the period is 2. So it takes 2 of these units, we don't know what the units are, to kind of come back to what it originally was here. So that's basically what the period is. And the frequency is 1 over the period. So if the question is giving the frequency of the oscillating object, it's easier to convert that to the period, or whatever you think is easier to input into the equation. See, so yeah, as I mentioned before, these are derivatives of each other. So one thing to note is that we see that, so derivative is basically the slope of the function. So if the slope is negative, derivative will be negative. So as you see, this is negative, 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 and then here is 0, right? So at the point where it's 0, the velocity is equal to 0. So all this whole thing, the slope is negative. This will be also equal to a negative value. So one distinction I want to make, although this slope is negative, the value is positive, but this value is negative because this slope is negative. And we can follow this all the way here. So the points where it's 0, here, here, where the slope is 0, here, 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 and here, these points will be 0, as you can see. And then the same with acceleration and velocity. So the points where this the slope for the velocity function is 0, this acceleration value will be 0. So here, as you can see, here, and I hope you guys can see my mouse, and here, here, and here. What else? Yeah, so I think that's the most important thing. And then one more thing I want to ask, you guys can answer in the comment section. So Dr. Anderson talked today about a shift between acceleration and the position curve. So what is this shift? What is the difference between the position curve and the acceleration curve? There are basically 2 main examples that kind of like exemplify this simple harmonic motion. One is the mass on a spring, and the other, as we'll see later, is the pendulum. So one thing to note about this is that there are kind of two orientations for mass on the string. That you can have this vertical orientation where there's always going to be some type of force acting on it because of gravity, and then you'll have the horizontal mass on the spring. We'll see both in a second. But one thing I want to note here is whenever you see a spring, think Hooke's law. Usually you'll be given two of these and asked to find the third value. It's usually how equations work. But yeah, so for each spring they have a specific spring constant. And one thing I want to note is that a lot of the times they'll be asked what will affect the period of the oscillations for a mass on the spring. Only these two values will affect it. Only the spring constant and only the mass will affect the period of the oscillations. So that's definitely something to keep in mind. A lot of the times the problem will give you extra information that you don't need. Is usually just to trick you. Or sometimes you can use this other information to find kind of like a value that you need to find the answer. And my worksheet has examples of all of this. So definitely try to do that. There's some difficult ones on there towards the end. So definitely try to challenge yourself and do the best you can on them. And we'll go over it on Tuesday and Thursday. So what else can I say about this? So yeah, keep in mind displacement. So if X is in its equilibrium position, especially for this, these horizontal mass on springs, if it's at the equilibrium position, there's going to be no force acting on it because X is equal to 0, right? So always keep in mind how far it's traveling, and always keep in mind the direction where it's traveling. So this is going to be, you'll be able to understand these more through actually, hands-on, like doing equations and trying to solve problems by conceptually understanding what is going on. So just as a little reminder, if an object is traveling to the right, it's always a positive velocity. If it's traveling to the left, it's always negative. If it's traveling up, positive, down, negative. So always keep that in mind, regardless of the orientation. So if this end was on here, was on the right side, and it's traveling to the left, it would still be negative, just like this is negative. Yeah, it's definitely something to keep in mind. And sometimes it does trick people, the orientation, and it's a terrible way to lose points. So last thing is the pendulum. So ignore this stuff on top. I just took this from online, but it really showed what I wanted to show. So what affects the oscillations for a pendulum? Does the mass affect it? Does the length affect it? Does how hard you swing it? So what affects these periods? You'll see that it's only the gravity of the environment that you're in and the length of the string. So the larger the length, the lower the period. They have an indirect relationship. The larger the gravity on Earth, I'm sorry, not larger period, larger angular velocity. Yeah, so the larger the gravity, larger the angular velocity, and yeah, and so we see that angular velocity and period are inversely related. So increasing the length will increase the period. Increasing the gravity of the environment will decrease the period. And so, yeah, that's all of it for today. So definitely try to challenge yourself with the questions in my worksheet. And yeah, thank you guys so much for watching, and I hope I can be of use to you in the future.